Acupuncturist treatment rooms are considered patient care spaces and therefore require redundant equipment grounding. The 2020 National Electrical Code, or NEC, defines patient care spaces as healthcare-related facilities where hazardous currents or voltages may be present during normal patient care. This encompasses areas like acupuncturist treatment rooms, especially when electrical equipment such as acupuncture machines are utilized. Redundant equipment grounding is a critical safety measure mandated by the NEC to safeguard patients from the risk of electrical shock. This risk arises from potential faults within the primary grounding system. The process of redundant grounding involves the installation of a secondary grounding electrode system. This system is independent from the primary grounding arrangement. The purpose of this secondary system is to provide a reliable backup grounding pathway. This pathway is used for electrical current to flow should a failure occur in the primary grounding system. The NEC mandates redundant grounding in these spaces to ensure that a low-impedance path to ground is always available. This is to minimize the voltage on exposed conductive surfaces should a fault occur. In a typical electrical system, the grounding electrode system consists of items like ground rods, ground rings, or connections to metal water pipes. The grounding electrode conductor connects the system to the electrical service equipment. The equipment grounding conductors, often green or bare wires, bond the non-current carrying metal parts of electrical equipment back to the service equipment. In patient care areas, the NEC adds another layer of protection with redundant grounding. This means having two separate and distinct grounding paths. One common method to achieve this is by using a supplemental grounding electrode. This is connected to the equipment grounding system within the patient care space. Firstly, the primary grounding system, as described earlier, remains in place. This typically involves a connection to a grounding electrode system and equipment grounding conductors that run with the branch circuits. Secondly, the redundant grounding system involves adding a supplemental grounding electrode. This can be a ground rod driven near the treatment room or a connection to a metallic water pipe. A separate grounding conductor is then run from this supplemental electrode to a grounding point within the treatment room. This could be a grounding busbar or a designated grounding terminal. This provides an alternative path for fault current to return to the source, reducing the risk of electrical shock. The NEC specifies requirements for the size and type of grounding conductors used for both the primary and redundant grounding systems. For example, NEC Table 250.122 provides guidance on the minimum size of equipment grounding conductors based on the rating of the overcurrent protection device in the circuit. The supplemental grounding conductor for the redundant system should also be sized appropriately following the NEC guidelines. It's crucial to ensure that all grounding connections are properly made and are mechanically and electrically sound. Loose or corroded connections can compromise the effectiveness of the grounding system and increase the risk of electrical shock. Regular inspections and testing of the grounding system are essential to verify its integrity. This includes checking the resistance of the grounding electrode system and ensuring that all connections are tight and free of corrosion. In addition to the redundant grounding requirements, the NEC also includes other provisions for electrical safety in patient care areas. These include requirements for ground fault circuit interrupters, or GFCIs, in certain locations, as well as restrictions on the use of extension cords and flexible cords. Ground fault circuit interrupters are designed to detect small imbalances in current flow. They quickly de-energize the circuit to prevent electrical shock. GFCIs are typically required in wet locations, such as bathrooms and near sinks. The NEC also restricts the use of extension cords and flexible cords in patient care areas. This is because these cords can be easily damaged or misused, creating a potential shock hazard. Where portable equipment is necessary, it should be connected using heavy-duty cords that are specifically approved for healthcare applications. Proper wiring and grounding are crucial for safety. Electrical systems must adhere to the NEC to minimize electrical hazards. Ignoring these regulations can have serious repercussions, especially where patient safety is at stake. Always consult with a qualified electrician to ensure compliance with all applicable codes and standards. Grounding electrode systems are essential components of electrical safety. They provide a low impedance path for fault currents to return to the source, reducing the risk of electric shock. The NEC specifies detailed requirements for the installation and maintenance of grounding electrode systems to ensure their effectiveness. In addition to ground rods and water pipes, other types of grounding electrodes are permitted by the NEC. These include ground rings, concrete-encased electrodes, and other approved electrodes. The selection of the appropriate grounding electrode depends on factors such as soil conditions and the availability of suitable grounding mediums. The NEC also addresses the bonding of different metallic components within a building's electrical system. Bonding involves connecting these components together to create a common ground reference. This helps to minimize voltage differences between different metal parts and reduces the risk of electric shock. Proper bonding is particularly important in patient care areas where patients may come into contact with multiple conductive surfaces. Furthermore, the NEC requires that all electrical equipment used in patient care areas be listed and labeled by a recognized testing laboratory. This listing ensures that the equipment has been tested and found to be safe for its intended use. It's important to only use listed equipment in patient care areas to minimize the risk of electrical hazards. Periodic inspections of the electrical system in patient care areas are also essential to identify any potential problems. These inspections should be performed by qualified personnel who are familiar with the NEC requirements for healthcare facilities. During the inspections, the grounding system, wiring, and equipment should be checked for any signs of damage or deterioration. Any problems that are identified should be promptly corrected to maintain the safety of the electrical system. Acupuncturist treatment rooms, due to the potential use of electrical equipment, fall under the stringent electrical safety requirements of healthcare facilities. Redundant grounding, along with other safety measures, is vital to ensure a safe environment for both patients and practitioners. ENEC, specifically Article 517, provides detailed guidance on the electrical requirements for healthcare facilities, including patient care spaces. This article covers various aspects of electrical safety, such as wiring methods, grounding, and the use of isolated power systems. Isolated power systems are sometimes used in critical care areas to provide an extra layer of protection against electrical shock. These systems use a special transformer to isolate the electrical supply from ground. This makes it more difficult for a fault current to flow through a patient, reducing the risk of electric shock. The NEC also includes requirements for the testing and maintenance of isolated power systems to ensure their continued effectiveness. Understanding and adhering to these NEC regulations is paramount for maintaining electrical safety. This ultimately safeguards patients and healthcare providers from potential electrical hazards.